Hi guys, I'm redlaserbm, and in this video, I'm going to show you how to download, install, and run the Battles 2 Eco Simulator. All right. So, real quick about this this simulator. So, what the simulator is that it is a Python library dedicated to simulating eco and farms in Battles 2. So it's a really useful tool. For optimizing existing flowcharts, coming up with new flowcharts, and theory crafting them before playing the game. It's relatively easy to install and operate, and the purpose behind this video is to help anybody who wants to use the sim but doesn't know how to run it or doesn't know how to code. The purpose of this video is to get you up and running and using the code within 20 minutes. All right. Now, if you're already experienced and you know how to run Python code, then all you got to do is you just type pip install b2sim in the terminal. You get the code in your computer, and you can follow along with the tutorial files that I've posted here to run the simulator. But I'm assuming here in this video that you're kind of a noob when it comes to coding. So before you can run Python code, you need to have Python installed on your computer. So we're going to get started with by using the Anaconda distribution. We're going to download Anaconda onto our computer. Let's go ahead and click on download. And there you see it's going to start downloading Anaconda onto our computer. Heads up, this installation process will take a few minutes. So what I'll do is, with the power of video editing, I'll just skip straight to the good stuff once this installation is complete, and then we'll continue from there. Okay, it's the Anaconda has finished installing, or sorry, not installing, it's finished downloading. Let's go ahead and open the file. Give it a little bit here to open. So I've clicked on open, but it might take a little bit to run, so there you go. All right. So now that we have that ready to go, we're going to go ahead and click next to continue. Just click agree on here. I'm not really sure if this option matters, but I'll just install with admin privileges. I'll go ahead and install in the default folder. Then I'll just click that check mark right there. Hit install. Might take a little while here to install at this point. This part of the process right here, the very last part of the installation, that's the part that takes the longest. You know, you get 90% of the way through in like 5 seconds, right? And then the last 10% takes like 5 minutes. But that's how it is sometimes with installing these programs. Now, while this is installing, what I will say is that another program that I recommend that you install to make it easier to code is Visual Studio Code. All right, Visual Studio Code. It just has some cool extensions, which make it easier to code in Python, like nice quality of life improvements. All right, we have completed installing Anaconda, so now we have Python on our computer, but we haven't yet installed the simulator on our computer. So we still need to do one more step. So here's what we're going to do. All right, we're going to type in Anaconda prompt. And now, what we're going to do here in the prompt is we're going to type pip install b2sim. And what it'll do is that it will download the code onto your computer. All right. And once you have the code installed on your computer, now you're ready to go. Now we can open up our code editor, and I can show you how to run the code. Actually, real quick, before we get started with coding, if you use Visual Studio Code, you'll want to have these extensions installed. Maybe this one actually isn't necessary, but the other ones are. If you download the Python extension and the Jupyter extension, the other one should end up downloading automatically. Right, and this is what will give you all those quality of life improvements to make it easier to operate the simulator. Okay, now that we've gotten everything installed and we're ready to run the code, let's actually run the code. Here I'm going to show you how you can operate the B2Sim simulator with ease And to start things off, we're going to create a .ipynb file. Or what I've actually done here is that I've opened up a .ipynb file. So if we go on the internet here and we go to our B2 simulator, right, you'll see that there are some tutorial files, right? And what I've done is I've actually downloaded the tutorial files to my computer, which if you ever need to do that, what you can do is that you can actually just click on the file, and then you can download the raw file right here. So that's how you can download a file from the repo onto your computer. So, and that's just in case for whatever reason you don't want to clone the repository to your computer. Again, the whole idea behind the pip install is that you're able to install the code on your computer without having to clone this repo and go through all of the geeky Python stuff in order to get the code up and running. But anywho, back to this thing right here. So the first thing we're going to do is that we're going to import B2sim as B2. You hit Shift Enter, and that will run the cell. And now this cell has the B2sim functions available. We just have to call them by putting B2 before them. All right. So there is a 5-step process that you have to follow when running simulations. You're first going to determine the lengths of the rounds. And actually, let's zoom in a little bit here so you can kind of see things a little better. So maybe even zoom in. Probably that's pretty good right there. I'll kind of get this out of the way there as well. So there's a 5-step process that you have to follow in order to create a simulation in the B2sim module. You first need to determine the rounds using the rounds class. You want to determine the lengths of the rounds. You want to determine the farms that you have. You want to specify the purchases you intend to make and the eco flowchart you intend to follow. Then you're going to define the initial state of the game, and finally run the simulation to the time that you want to simulate to. All right. Now, the process obviously is going to vary from simulation to simulation depending on what you actually want to simulate. So if you're running an eco comp, for instance, then you don't need step 2. If you're playing around with supply drops or boat farms or heli farms, step 2 is going to look a little different for you. But this is the general procedure. So we're going to run through a basic example, and what this basic example is we're just going to assume that it is the start of round 14. I have access to 2 banana plantations cross-pathed in the usual way. We're going to have 800 eco, right? I'm going to assume that this is just before the start of round 14, and then we're going to proceed to the start of round 17. All right? Now, again, we want to follow that 5-step process. Actually, one more thing about the simulation too. I'm going to assume that the whole way through that we're going to use group black eco. All right. And for now, I'm going to keep this example quite basic. So there isn't going to be any purchases or any changes in eco. We're just going to eco group blacks the whole way through, and we're not going to purchase any more farms or anything. So it's just going to be a simple simulation. The first thing we need to do is we need to determine the round lengths. And the way that we're going to determine the round lengths is that we're going to do something called rounds is equal to B2 points rounds. And then we're going to put a number inside. And that number is going to be the stall factor. All right. So the stall factor is a number that ranges from 0 to 1. It influences the lengths of the rounds. 0 denotes a fully anti-stalled game, while 1 denotes a fully stalled game. So there was data collected by Spoonoil and Ninjayas back in October 2022. That is the data that I'm using to compute the round lengths using these stall factor numbers. Obviously, I modified them to account for the new rules for round lengths that were implemented recently in version 2. So, in practice, you'll probably want to do stall factors between like 0.1 and 0.5. It's pretty rare to have games that go beyond those numbers. If you need to do something, if you need to be more detailed with how you set your rounds, you can actually set the round lengths manually if desired. But for now, let's just stick to this simple construction. I'll do B2 point rounds 0.1. So this will be a 10th stalled game, fairly anti-stalled game. All right, next thing we're going to do is we're going to define our farms. So you want to define the farms that we have at the initial time. So I'm going to say farms, and I'm going to make it a list. All right, and in this list, I'm going to do a couple of these B2 init farm calls. All right. So each init farm call obviously represents a farm that we have, right? Now there are two arguments that we need to put in here. So the first argument we need to specify is the time that the farm was either purchased or last upgraded. The second argument we need to put in there is the upgrades that we have. Obviously, we're dealing with a 320 farm, right? The reason that purchase time is important is because farms have different rules for payout for the round that they're purchased on and subsequent rounds. So the payout rules are slightly different. We don't need to be that precise with our purchase times, but in practice, what'll happen is that maybe your first farm is purchased on your first banana plantation would have been purchased in round 7. Maybe your third or your second banana plantation would have been fully upgraded by, just before the start of round 14. If you need to specify, so right now if I put in a number, right, this number just specifies the amount of game time in seconds. But if you need to specify a round, what you can do instead is rounds point get time from round. And I'm going to let's put in 7. So our first farm is going to come from round 7. That's the time that the farm was 320. And then I'm going to say the second plant. So the second plant, we got it at round 13.9. So 9/10 of the way through round 13. Make sure you're hitting Shift-Enter on your cells, by the way, to run through them. All right. Now, again, in your general simulation, right, if you have eco sends that you want to, or if you have an eco flowchart that you intend to follow, or if you have purchases that you intend to make, you'd want to specify that flowchart. You want to specify the so-called eco queue and buy queue. In this specific example, I'm not going to go through that, but I'll go through it. The tutorial files go through it in more detail as you read through them. So step 4 is, this is where we define the initial state of the game. So what we're going to do here is we're going to create a dictionary, which is going to contain all the arguments that the simulator needs to run the simulation. So we're going to create a dictionary, right? We're going to let's specify our starting cache. Let's specify our starting eco. So I'll assume that we start with 0 cache, 800 eco. I'm going to say, so let's specify our eco send. I won't go into too much detail about how the eco send call works for now, but the syntax isn't too hard if you just need to specify an eco send to start with. So here I'm just going to say, hey, we're going to start with group blacks. So let's do b2.ecosend, send name group blacks. All right. Next, we're going to specify our round lengths. So we already did that earlier with the rounds class. I'm just going to put in rounds. All right. Let's declare our farms. You see that there's quite a bit of parameters, and really the hardest part about using the simulator isn't actually the simulation, it is setting up the simulation. Finally, we're going to set the game round. Now, I said I wanted to start the simulation at round 14, but I'm actually going to put 13.99. And the reason I'm going to put 13.99 is because I want to account for the farm payments that occur right at the start of round 14. All right. The way that I coded the simulator, if I start the simulation at some specific time and there are payments slated to occur at exactly that time, the simulator won't process those payments. There are reasons why this implementation has to be this way. There were alternatives that were not as desirable. So there's downsides to this implementation, but I think it's overall the best implementation. So I put 13.99, and that just makes sure that, okay, we're essentially starting on round 14, but I'm making sure to account for the payments that are actually going to occur on round 14. All right, now that we have the initial state set, we are finally ready to simulate. And simulation, again, it is fairly easy. What I'm going to do is let's create our game state, and we're going to initialize the game state class using the initial state that we defined earlier. So game state equals b2.gamestate initial state game. All right. Now, once I've initialized the game state class, then I'm ready to simulate. We'll do game state. And the way to simulate is that you use the fast forward method. So fast forward. And I said I wanted to go to round 17. So let's do target round equals 17. One thing that we want to do at the end, whenever we finish our simulation, we want to see what happened in the simulation. So I'm going to do the view cache eco history method. That's going to let me see what exactly my cache and eco was doing throughout the course of the simulation. It also has some other goodies for analyzing how effective our farms are throughout the simulation, right? And then, let's see here, one more thing. I'll print out a little message which just tells us what the current cache and eco are. So this is just useful for, you know, when you're dealing with classes in Python, right? You can always directly access the class variables. You don't need to like, you don't need to like access or write like a method or something or do whatever. You could just do game state point cache, game state point eco, and that'll give you access to the cache and eco in the game state. All right. Last thing I'll do here, just for debugging purposes, we'll write a log file. The log file is interesting to look, it's useful to look through in case you just want very specific details about what happened over the course of the simulation. So for me, it's useful for debugging purposes in case I find an error in the code. For you, you probably won't use it too much. This is going to be your bread and butter right here, this game state point view cache eco history method right here. Let's hit Shift Enter. And here you can see we have a graph which showcases, it shows how our cache evolved over time, and it also shows how our eco evolved over time, right? So we can see exactly how our ecoing went, exactly how our farming went, all within this very succinct graph. We also have some stats where we can see key events and when those events occurred. So here we have the times when the round started. We have the time that this was just a simulation start time actually, but here you can see okay, we changed to group blacks at time 284.8, but that's really when the simulation started. Here's a tidbit that's actually really useful right here. With each farm that we have in the simulation, you can see the amount of money that the farm made over the course of the simulation. You can also see the amount of money that we spent on the farm over the course of the simulation. So reason expenses is 0, even though those farms costed money, is because we didn't spend money on farms during the simulation, right? So we can see the profit the farm made over the course of the simulation. And we also have this measure called eco impact. And what eco impact is measuring is basically how good the farm's income was in terms of eco. Right. And it's a good measure. It's a good statistic for measuring eco farm trade-offs, whether it's better to, go for eco or go for farms. This is really good for gauging, okay, if I have the eco lead, but I'm behind on farms, who really has the lead in income generation? Right. So, and that statistic, again, you can read it more. You can read more about it in the document, how it's measured. It's not a hard computation at all, but. Once we've worked through all this, this is your very first simulation using B2Sim. Again, throughout this tutorial folder that I've put in the repo, there are more files which explain how to use the code. But I just wanted to make this video so that people who were who kind of, like people who just didn't know how to code or people who had no clue how to operate the simulator. I just want to make sure that those people had an easy resource to get started using the simulator. So hopefully this video helps, and happy simulation.